Okay, we are going to wrap up this section on 5.2 here, talking about probability, two-way tables, Venn diagrams. It says here that a study found that 57% of students have smartphones, 30% have tablets, and 18% have both. Number one, it says find the probability that a randomly selected student has a smartphone, or, I'm going to circle the word or there, or a tablet, okay? When you see the word or there, a lot of times that indicates that you want to think about using that formula. I'm going to let S represent the event that a student has a smartphone, and that T is the event that a student has a tablet. And the formula that is on the formula sheet says to add those two probabilities up, but then subtract off the intersection, so that we are not counting that twice. Okay, so what I think you're going to find helpful with these problems, especially when it's talking about two events and they're both occurring, things like that, is a lot of times a two-way table, making that really helps answering these questions based on probabilities. It makes it so much easier. Okay, so let's go ahead and we're going to title our column here S for the student has a smartphone, and then the complement to S, meaning they do not have a smartphone. This row can be that they are owning a tablet, and this row here will be that they do not own a tablet. Okay, so we're given percentages here, not counts. So when it says 18% means that they both have a smartphone and a tablet, we would want to find the intersection of where they have the smartphone, have the tablet. Right here is where we would want to put the 0.18 for 18% here. Okay, it's also telling us, and you got to read carefully where you should be putting these percentages. It says 57% of the students had smartphones. That means the total of this column should be 0.57. Okay, so if we were to if we know these two have to add up to 0.57, that means this missing percentage in here would have to be 0.39. Okay, they also share with us up here that the total number of tablet owners in terms of percents is 30%. Okay, so that means the total for this tablet row should be 0.30, leaving this gap here would have to be 0.12. Okay, keep in mind these are percentages, so that means the grand total of the far right column or the very bottom row should total to be 100%. If I fill that in, that helps me fill this gap here. 0.3 plus something has to total 1. That sum has to be 0.7, which means that if these two things add up to be 0.7, this would have to be 0.31, making that column total 0.43, which makes sense because these should total 1. Okay, so now we have our two-way table set up. We should be able to pull these values we need to use this formula. We're looking for what's the probability that someone owns a smartphone. Okay, that's simply the 0.57, so I'm going to fill that in underneath here. The probability that someone owns a tablet, that's the 0.30, and then the probability that, or we want to subtract off that they own both. Now, I suppose we certainly did not have to make this two-way table in order to answer this question, because these are all the percentages that we were given for this problem, but I think the two-way table will definitely prove helpful when we're answering some of these other parts to this problem. So let's look at part B. It says find the probability that a randomly selected student has a tablet but not a smartphone. Okay. Now you notice they use the word but here, but what's actually implied is they're saying that the student has a tablet and they do not have a smartphone. Okay, so they didn't actually put the word and in here, but it is most definitely implied that we're looking for this situation here. Okay. So I'm just looking for the intersection of where do the tablet people overlap with the people who do not have smartphones, and I can just pull that number right off the chart there. I can see that that's 12%. Okay, let's go ahead and try the next one here. We're looking for what's the probability that a randomly selected student has neither a smartphone nor a tablet. Again, they're not using the word and, but we're definitely talking about someone who does not have a smartphone and they do not have a tablet. So again, the intersection of not having a smartphone with not having a tablet would be this number here, the 31%. Okay, and then down at the bottom here, okay, it says find the probability that a randomly selected student has a smartphone or a tablet, but not both of them. Okay, not both. Now, a lot of times we define the word or to mean one or the other or both, okay, but this is saying not both, okay? So what we're actually looking at here is we want these two scenarios. Someone has a smartphone, means they would not have a tablet, so we want that probability. Plus, we want, if they don't have a smartphone, then we want them to have a tablet. Okay, we need these two separate probabilities. That way, they have one or the other, but they're not having both. Okay, so we can pull this from the table. Having a smartphone but not having a tablet, that's the 0.39. Okay, not having a tablet, but not having a smartphone but having a tablet, that's the 0.12 for a grand total of 0.51. Okay, on the next page, this is a really good example. It's titled Who Reads the Paper? And it says here that in an apartment complex, 40% of the residents read the USA Today, but only 25% read the New York Times. 5% of the residents actually read both of these papers. Let's suppose that we select a resident of the apartment complex at random and we record which of the two papers that person reads. Okay, so we want to make, first of all, part A says make a two-way table that displays the sample space of this chance process. So what we're referring to is whether someone reads the USA Today, or if they do not read the USA Today, I'll just call that the complement there. Okay, the other paper was the New York Times. That'll be that they read it, or the complement to that is that they do not read the New York Times. Okay, so first if we can go through here and kind of fill in these percentages. It says 40% read the USA Today. Okay, so that means this whole first column should total the 40%. Okay, this again is percentages similar to the previous problem. 25% are the New York Times, so the sum of that row should be 0.25. Again, keep in mind that the sum of the far right column and the very bottom row should total the 100%. Okay, now the other percentage they give us, and it's really easy to overlook because they chose to spell out this in words instead of giving you numbers, 5% reading both. Okay, so I'm looking for the intersection of USA Today and the New York Times. That would be 0.05. And then I can just go through, now that I know what some of these rows or columns need to total, I can just fill in the missing pieces here. Okay, this would have to be 0.75. That makes that 0.4. Okay, so there is my two-way table here. Okay, now for part B, I guess that's part A here. Okay. Part B wants us to make a Venn diagram. Okay, so a Venn diagram is when we have those circles, and if the events are overlapping or intersecting, then maybe those circles tend to interlock. So I'm going to go ahead and let this red circle represent all the people in this apartment complex who read the USA Today. And we do know that some people read both papers, so I'm going to make these two circles interlock. The blue one will be the percentage of people who read the New York Times. I encourage you, when you are making a Venn diagram, if you are given what the overlapping percent, like in this case, they read both papers, 5%. Always start by putting that intersection amount in that overlapping area, 0.05. Okay, and so we're going to think through here. They told us that the total percent of people who read the USA Today is 40%, but that includes this 5%. Okay, so that means what I need to fill in for this other part of the circle is 35%. Same thing with the New York Times. The total number of readers for the New York Times is 25%, but that includes this 5%. That means this is 20. You'll notice, though, when we add these up, the 35, 5, and 20, that only totals 60. Okay, that only totals 60. And so that's why we put this rectangle. This represents the entire sample space. Anything outside of either of those circles represents someone who does not read the USA Today, and they do not read the New York Times. And so if I've used up 60%, that means out here, 40% of the people are not reading either of these two papers. Okay, so now I've done part B, so let's go ahead and take a look then at part C. It says find the probability that the person reads, okay, this is important, at least one of the two papers. Now we touched on this back in video A. This is a really crucial phrase. I put a little note here for you. It says that none is the opposite or complement of at least one. Okay, none is the complement of at least one. So if you have a problem and they're asking you what's the probability that someone reads at least one paper, then you could calculate that probability by doing 1 minus the probability that they don't read at least one paper. That's the complement. Now think about what not reading at least one paper means. If you're not reading at least one, then that means that you are reading none. You're not reading any papers, okay? So let's go ahead and kind of spell this out here. We're looking for the probability that someone reads at least one paper, okay, at least one. Okay, would be found by taking 1 minus the probability that someone reads no papers. Okay, reading no papers is the complement to reading at least one. Okay, and then we could go through and say, well, we figured out what that percent was, that they don't read any papers. That's this 40% here. Okay, that they're not reading any papers at all. Okay, which is also what this intersection is here. They're not reading the New York Times. They're not reading the USA Today. So I'm subtracting that, and I'm getting as my answer 60%. Okay, and then finally, part D to this says find the probability that the person doesn't read either paper. Okay, so they're not reading either paper. Probability reads no paper, and we certainly know what that is because we use that right here. That is the 40%. Okay. All right, if you were to take a look at the example underneath this, this is just another two-way table problem asking you some various probabilities. I've filled that in for you just so you have another example to reference excuse me, and look at. I want to wrap this up here with looking at these last two examples. Number 15 is extremely important here. But let's take a quick look at example 14. It says here 29% of kids got an A on a math test, 22% got an A on the physics test, and 57% didn't get an A on either test. Okay, we want to be really careful with the wording of this. And this is why either making a two-way table or making a Venn diagram is going to prove to be very helpful for these types of problems. Okay, so we're talking about, either, yeah, they got an A on the math test, or we'll let this represent they did not get an A on the math test. Physics can represent they got an A on the physics test, and this will be the complement to that. They did not get an A on the physics test. Okay, so let's see if we can fill in what we know here. 29% got an A on the math test. That's going to be the total of that math column. 22% got an A on the physics test. That'll be the sum of that physics row. We know this has to total a 1 for 100%. We also know that 57% of the students did not get an A on either test. Okay, so that means no A on the physics, no A on the math. This block right here is the 57%. Okay, then we can just kind of go through it, and we should be able to fill in some of these. For example, we should be able to fill in right here should total 0.78. Okay, this total down here should be 0.71. Okay, if this total is 0.78, it means this gap right here would have to be 0.21. Okay, and you just kind of use what you know about how numbers add up here to sort of fill in these missing pieces. Okay, so here is a two-way table that we could use. If you prefer Venn diagrams, I'm just going to illustrate very quickly here how a Venn diagram may have looked for this, and it would be totally fine if you were to make a Venn diagram for this particular problem. Okay. All right, so we can see here that the individuals who got both an A on the math and the physics would be represented by this intersection of these two interlocking circles. Okay, I know that to be 0.08 from me making that two-way table. Okay, I also know that the total number of individuals who got an A on the math test was 0.29, or that's the percent. That includes this 0.08. That means over here this would be 0.21. Using that same logic for physics, it totals 0.22, but that includes that 0.18, so this would be 0.14, and then 57% is what's outside there in that other sample space. They did not get an A on either. So it says, what percent of kids got an A on both tests? Okay, so I'll just use an M for math and a P for physics. Okay, this would be on both, the intersection, that is the 8%. It says what percent of kids got an A on the math test, and they didn't get an A on the physics test. So I'm looking for the intersection of where got an A on the math intersects with didn't get an A on the physics. That's that 0.21 there, okay? All right, so this last problem is really, really important, and it generally is pretty tricky for students. We're going to start out with this first part here. It says, Andrew's grandma gives him either a chocolate bar or a bag of Skittles every Halloween. Okay, so he gets one or the other. The probability that he gets a chocolate bar is 34%. It says here, what is the probability of getting a chocolate bar 3 years in a row? Okay, so we're looking for 3 chocolate bars in a row. Okay, and we know for any given year, he's got a 34% chance. So if we're talking about 3 years in a row, we could write it like that, or we could write it as 0.34 cubed, and we end up getting that he's roughly got about a 3.9% chance of getting 3 chocolate bars in like 3 years in a row like that. Okay, now that one wasn't too bad. Let's take a look at this one. It's really number 3 that you got to watch out for. It says, what's the probability that he is not getting a chocolate bar 5 years in a row? Well, we were given the probability of him getting a chocolate bar for a single year. I could certainly calculate what the odds would be of him not getting a chocolate bar for a single year, just 1 year. Not getting a chocolate bar would be the complement of him getting a chocolate bar. So that would be 66%. But this problem is asking, what are the odds of him not getting a chocolate bar 5 years in a row? Okay, so 0.66 or 66% are the chances for 1 year. I need to multiply 0.66 times itself 5 times in a row, okay, or raise it to the 5th power there. He's got a 12.52% chance that he would get not a chocolate bar 5 years in a row. Okay, now here's the tricky part with number 3. It says here, for the next 4 years, what's the probability of getting, and here's your key phrase here, at least 1 chocolate bar? Okay, when you see the phrase at least 1, you need to think to yourself, that means 1 minus the probability of none. Okay, you want to kind of memorize that. That converts to 1 minus the probability of none. Okay, now if this just asked you what's the probability that he would get at least 1 chocolate bar for just a given year, that's fine, but the key here is we're talking about 4 years in a row. So we want the probability of at least 1 chocolate bar in 4 years. Okay, so that means I need to do 1 minus the probability that he's gotten not just no chocolate bars, but no chocolate bars for 4 years. Okay, remember when we were talking about doing this multiple years in a row, that's when we had to like get an exponent there, 3 years in a row, 5 years in a row, 4 years in a row, no chocolate bars. Okay, now we know up here what it is for him not to get a chocolate bar just for 1 year. Okay, but I need to show that he hasn't gotten a chocolate bar for 4 years in a row. So this is the crucial part, that we're raising that 66% to the 4th power, and then that is being subtracted off of 1. That's going to give us an 81% chance there. Okay, there are going to